So, alright guys, solve this question here, right? So if I copy this and paste it here, alright. So this is the question, and then what is given, let's read it out, right? So it's saying write an efficient algorithm that searches for a value called target in a m cross n integer matrix, which is called matrix A, right? This matrix has the following properties. Integer in each row are sorted in ascending order from left to right. Integer in each column are sorted in ascending order from top to bottom. So we have to find that. So one way to find right, guys, to target, like there is some target value, right? Let's say it's 40, right? So one way is like go from search every element, right? So its time complexity could be m cross n, right? In worst case, we have to minimize from that, right? So one thing we can do is go on every row, right? Go in each row and try to do the binary search, right? So it would be like we have m rows and log n. This is another way, right? What is the third way? Can we do it like more optimized than that, right? More optimized version from that is, you see here, this is sorted, this is increasing, this row is increasing, right? And this column is also increasing order. So we cannot decide, okay, where to go, like here to go or here to go, right? Similarly for this. So we have to find that where we can do like where we can eliminate something, right? Yeah, either left. That's why we can apply binary search, right? So we can look at this, right? Look at this part. It's increasing and increasing. It's not decreasing at all, right? Like this, right? It's always increasing. This part also, it's only increasing, right? So what we can do, we can start from here, right? We can start from here and check, okay, the target is this side or this side. If it is this side, so our target is 40, right? Then what we can do, we go left side, right? So we are here, right? Here, then here. Where is target? Target is this side because it's greater. We come here, right? Where is target? This side, here. Where is target? This side. Where is target? This side. We found the target, right? We will do it till the end. So let's say worst case. In a worst case, where we have to come from? We have to come from here to here, right? In worst case. So what will be the time complexity in this? In this case, our time complexity will be m plus n. Right, it's the most optimized version we can do in this. So let's code it out, right? Okay. Here we have integer n is a matrix dot size. Here n equal to matrix 0 dot size, right? uh, so what we do, like enter row is equal to 0, right? Enter column is equal to n minus 1, right? So here while row is less than m, right, and column is greater than equal to 0, right? If it is the case, what we will do, if a matrix row comma column is equal to target, in this case return true, right? Return true, right? Okay, one more thing is like if that value is less than target, right? So if the matrix row column is less than target, right? If it is like that, then we have to go right side, right, in the column side. So we have to go, like we are here, we have to go here, means we have to increase the row thing, right? Row plus, right? Else where column minus, right? Column minus. If it is not finding anything, then we will return false, right? Let me check if it is working or not. It's working here. Let's check now. Okay, it's working, guys, and we are one of the most top performers in this, so very good, nice also. Alright, then it's done. Let's do next question, which is find peak element, right? So peak element 2D grid, let me take this example from here, copy image, and I can paste the image here, right? Alright, and let's read out the question also, which is a peak element in a 2D grid is an element that is strictly greater than all of its adjacent neighbors to the left, right, top and bottom. Okay, like strictly greater than, it's not like less than, equal to, like that. Okay, so given a zero indexed M cross N matrix where no two adjacent cells are equal, right, you may assume that the entire matrix is surrounded by an outer perimeter with the value -1 in each cell. You may assume that entire matrix surrounded by outer perimeter, okay, in each cell. You must write an algorithm that runs in m log n or n log m time. Okay. So let's try this, guys, which is a very good question. peak is like, let's say this is 30, right? Every element here is less than, and this is also peak element. So we have to like find any one, right? So original matrix is this, guys, here. Okay, original matrix is this part. These are the outer, we are assuming that these are -1. Okay, so right, so what we have to do, we have to find what we can do. One, like we go one by one. M cross n is very easy, right? We go each element we search for, and into 4 also, because for each element we try to compare 4 times, right? Like all the 4 directions. Now, so how can you optimize this? We can optimize this like, okay, either we go from row wise, either from column wise, and find the peak. Means, let's say we are finding this element, right? Whatever the maximum element in this is 32, right? This is 32 in this. So 32 is so let's understand this, guys. First, let's say this is our array, right? So if we are finding this element here, so if left element is greater than this, then peak will be on left side, right? If we are landed here, then peak element on right side, right? So we can move from left to right in that case. But this is for 1D array only, right? 1D array. But we have 2D array, right? We have this 2D array. So what we have to do, we have to make this 2D array and take it into 1D array, okay? So what we do, we in each column, right, we find the maximum element, okay? So maximum element is 32, and we check, because if it is 32 is maximum, then automatically top and bottom of this element are less than this, right? So we just left with 1D array, which is left and right? So here what we can do is, so we will check, okay, is 32 greater than 16 years, greater than -1 years, and this is already greater than this, so this is a peak element for us, right? So that's how we can find, right? Let's say what we have to do, let's say we found here, right? We landed in this column, right? And we check, okay, what is the maximum element, which is 21. So automatically top and bottom are less than 21, right? So this operation will be of order of n, finding the maximum. Then what we have to do, we will check, okay, left or right. Right is greater, right? Right is greater. Then we move to right. So this element is now right column. We are here in the right column, okay? We are here in the right column now, alright? So if we are in the right column, we check again in that this might be possibly our maximum peak, right? But this does not guarantee the peak. Let's say if it was 40, so it's not peak, right? So we check the maximum in this column again, right? Then if it is not maximum, we have 40. Then 40 is the peak here, right? So that's how we will do. Let's code this out, guys, quickly. And it's order of n log n only, right? So int m is equal to mat dot size, n is equal to mat 0 dot size, right? Hold it. Then what we will do is whatever the maximum element will, okay. So what will be the like termination condition for us? We have to check that, right? Left, right, okay. Okay, we will put a condition after we find out why this is true, and we are at some index, right? So which index we have to go? Should we go in the middle? Okay, so int all right, uh, int low, right, equal to you can say 0, right? Int high equal to n minus 1. We are checking for columns, right? Then we have int mid equal to low plus high, right? Low plus high by 2, and what we will do, we will find the max index, right? Int max index is we have to a function, right? Function where we do pass our this met comma mid, right? Then we found the whatever the maximum. If we found the maximum element here with that function, then what we can do is left and right? So if max index is there, right? So let me show. Int left is mid is there, right? So column we have, row we have, row and column. So if mid, right, mid minus 1 it is equal to 0, right? If it is like this, then in that case we will go for left is equal to mid minus 1 comma maxi column, or no, maxi comma mid minus 1, else it will have minus 1, right? Int right is equal to if mid plus 1 is less than n, right? It is that maxi comma mid plus 1, right? Else it's also minus 1, right? Now if this maxi row and mid column is greater than left, and mat of maxi comma mid is greater than right also, right? Then what we will do, we will return what we have to return, guys? 1 1. Return the length 2 of array. Okay, we can return this maxi comma mid, right? If it is not case, right? Else if maxi comma mid is less than left, okay, like if it is like this, then high, right, less than left means it is greater, right? Then high is equal to mid minus 1, right? We are moving left, else low is equal to mid plus 1, right? That's the case. and if it is not finding anything, then return -1 in this case, right? So like, or let's say return empty list, right? So we have to find this function also, right? Whatever this function is, right? We have to define this. This function could be like this: private integer. It will return. It will be a vector different, right? Reference wise and integer int, and we are defining this max. We have to find int max is equal to 0, right? For we have to find the row, right? I is equal to 0, I less than m I plus plus, right? And maxi is equal to max of maxi comma mat I comma mid column, right? Okay, whatever. Right, and at the end we will return maxi. Let's try to while in while we have to put some condition, guys, right? We will put like this, okay? While low is less than equal to high, m is not like there, so rows, right? Then method size. Max e expression result used where? Oh, return, right? We have to return that. So we don't have to put it here, like if condition. Okay, it's automatic, right? I think. Yeah. Whatever. Heap overflow or what? Okay, so what's again? And mat max mid is greater than left, and let me find out the error in this, guys, first. What is the error? No, 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 no. Oh, it's not like this guys. Yes, I now found out because maxi we have to find maxi is the wrong answer, right? Okay. We have answer also guys, and answer equal to 0. Okay, if mat of row comma mid is greater than maxi, right, then maxi is equal to mat of I comma mid and answer is equal to I, right? We have to return answer here. Now we can try it, right? And I can do this also now because it was very wrong answer there. Okay, let's try it. Alright, it's working guys. It's in the defined bounds also, 100% runtime, that's good. And let's go back, right? Then matrix median. What is this question? The question is, you given a Tory matrix, this is a row by sorted. Task is to find the median of given matrix, right? This is some matrix. Explain we want the easier line sorted array. The array becomes this, so median. Okay, we will look at it later guys. Okay, thank you so much for watching, and yeah, we will meet